Hello friends, welcome once again to our channel SR Pharma Gyan. Today I am going to discuss about Anti-Markonivkov Rule, which is also called as Kharash effect or peroxide effect. In my last video I have discussed about the Markonivkov Rule, so I just recommend you go through the Markonivkov Rule first before proceeding with this video. So what Anti-Markonivkov Rule states: when there is a reaction between asymmetric unsaturated hydrocarbon with alkyl halide in presence of peroxide, the negatively charged part of the reagent is going to be attached with the carbon atom having more number of hydrogen. So if you see here, it is one hydrogen, here it is two hydrogen. So bromine will be attached with that carbon atom. So what will be the major product in this reaction? This will be the major product in this reaction. So what actually the main difference in this mechanism and Markonivkov rule mechanism is, this follows free radical addition reaction, and in Markonivkov rule it followed electrophilic addition reactions. So here free radical is involved, that's why free radical. The first attack comes from free radical to the substrate, that's why it is a free radical addition. In the previous Markonivkov rule, the electrophile first attack the substrate, that is unsaturated hydrocarbons, that's why that was electrophilic addition reaction. So in that, one important thing that we are using is peroxide. In presence of peroxide, this product will form, but in absence of peroxide, this bromine will be attaching to this carbon atom. Okay, so what actually the mechanism starts here is, we are using a common peroxide for this, that is benzoyl peroxide. And it undergoes heterolytic cleavage. So this bonded electrons will shift to this oxygen, another is going to shift with another oxygen. So what it is going to form? Okay, and due to this positive enthalpy of these molecules, the carbon dioxide is going to be come out from that. So one electron will be shifting here, one electron will be shifting here. It will be giving you a free radical of this and CO2. So this is the generation of free radicals. Okay, now C6H5 free radical is going to attack that HBr. So here also it will form, when it attacks, it will also form free radical. So what will happen? This will break together, the hydrogen will be reacting with that. It is forming C6H6 and bromine free radical. So one electron from this bond and this electron and one electron from this bond will form the bond between hydrogen and carbon, whereas one electron which has been shifted to the bromine will be reacting as a free radical. So that actually generates the free radical in the reaction, and the next step is that the bromine will be attacking the unsaturated bond. So here actually two products can form, two free radicals can form, CH3, CH, if bromine is attacked to that carbon atom, bromine, and CH2 free radical. CH2 free radical. If the bromine attack this carbon atom, what it will form? CH3, CH free radical, CH2Br. Okay, so here we are finding two free radical as formed. Now here we can also observe that the free radical that formed here is a primary free radical because this carbon is attached with one carbon atom only. Whereas here we can find the free radical has generated here is attached to the two carbon atoms. So this is a secondary free radical and this is a primary free radical. Okay, so here we formed two free radicals. CH3, CH, Br, CH2 free radical and CH3, CH free radical, CH3. So this is secondary free radical, this is primary free radical. Now if you see, the free radical has been generated if it is attached with the carbon atoms, three carbon atoms, that is tertiary free radical. Similar concept what we have discussed in Markonivkov rule, the CH3 is going to donate the electrons, so the unpairability of this electron is going to be reduced. So tertiary free radicals are always stable than that of secondary than that of primary, because for neutralization of this free radical property, here three carbons are giving electrons, whereas in secondary two carbon is attached, so this will not involve in giving the electrons. So two carbons are going to give the electrons, so that it will the reduction of the free radical property, it will be less than that of tertiary. So the tertiary free radicals will be more stable than that of primary. So this free radical will form predominantly than that of other free radicals. Okay. So now what actually the step is, next step is, this free radical has formed. Now that will react with the HBr. Hydrogen, again there will be a homolytic cleavage. Hydrogen will be moving to that. Now here we can observe that there is a two free radical formed, CH3, CH, Br, CH2 free radical. Another free radical that formed is CH3, CH, CH2, Br. Now if you consider the stability of these two free radicals, if you see the structure of primary free radical, secondary free radical and tertiary free radical, this is the primary free radical, secondary free radical and tertiary free radical, because three carbon is attached with this free radical carbon atom, carbon free radical. Now as already have discussed in Markonivkov rule, CH3 having a property for electron donating property. Here also it is donating the electrons. Now the more electron it donates, the free radical property of this carbon atom is going to be reduced. Okay. So here three carbon atoms are there to donate the electrons. So the more neutralization of free radical property in tertiary carbon atoms, whereas it is less than that of secondary and very less in primary. So more reduction in the free radical property gives stabilize to the free radical. So the tertiary free radicals are more stable than that of secondary than that of primary. So ultimately what happens? This free radical will be more stable. And then next what happens? It reacts with the substrate again. It is generating the free radical. This hydrogen free radical, it will be attacked the CH form CH hydrogen CH2 Br. So ultimately the Br is attached to the carbon atom which is having more number of hydrogen. So this is called as Anti-Markonivkov rule. Now coming to the reaction mechanism, there is a general reaction mechanism step. One is chain initiation, that was a free radical reacts with your substrates and it generates bromine free radical. So generation of free radical. Second is attack of free radical to the substrate. So that is called chain propagation step. Okay, so this substrate is reacting with bromine and it is generating new free radicals. So this is chain propagation step. Another is chain termination step. Whereas two elements like bromine and bromine, two free radicals to give a neutral product. So this is chain termination step. That means the free radical chain has been stopped by reacting two free radicals to give a neutral product. So this is chain termination step. Now coming to the reactivity of hydrogen halides, that HBr, HI, the reactivity of hydrogen halides. So as we have observed that HX generally it is denote that HX indicates HI, HBr, HCl and HF. This HF does not involve in this reaction due to the high bond strength. HBr generally it is involved in the reaction, whereas HI is easily breakable, that less bond strength, but the problem here is when it forms the free radical, iodine free radicals are combined together to give a chain termination. So the product is not going to give you an addition product, whereas iodine must be involved in the reaction with the unsaturated hydrocarbons, but these iodine free radicals combine together to give you iodine. So this hydroiodic acid is not involved in the Anti-Markonivkov rule, whereas HF due to the high strength it is not involved in it. So generally HBr it is commonly involved in this reaction. So friends, this is all about Anti-Markonivkov rule. I just prefer you follow the Markonivkov rule video first before proceeding with that. If you have any doubt or anything you could not able to understand, write me in the chat box. I will just reply on that. I'll try to reply on that. Thank you very much for listening. Have a nice day.